talking about modeling with proportions as we continue through chapter 4. We have discussed this before, so it should be a simple lesson for you. However, just like anything, it builds upon what you've learned, so the problems become a little more difficult. But to start off with, let's remind you that a ratio is a comparison of two numbers by division. Okay, you've seen that. If I'm going to compare two numbers such as A and B, then we could write that as A to B. We could write that as A to B, or we could write it as uh, A to B with just the word 2. Okay, and when we take two ratios and make them equal to each other, that is what we get when what we call a proportion. And how do we solve proportions? Sometimes it's easy to solve them like equivalent fractions, but when not, it's always important to remember how do I get them out of those fractions, and that is I cross multiply, and that would be A times D equals B times C. And I'm going to talk to you about, as I do these problems, remind you and hope that you will do this. When you solve these, if you will start at the bottom and think about that. Uh, Actually, let me make that one a little skinnier because it's kind of hard to read. Let's go with start at the bottom, keep it on that side, start at the bottom, and keep it on that side. Then when we get into some other types of problems, then you'll be in that habit. So it kind of forms a little pretzel, makes it easier for people to remember. Okay, so look at this first one. Solve each proportion and check. So if I do what I was just showing you and we start at the bottom, then I'm going to do write this one on that side and this one on that side, which is going to give me 10 times 3, which is 30, 2 times x, which is 2x. And then I'm going to divide both sides by 2 and find out that x equals 15. Now, to remind you, just what we finished talking about at the beginning of this chapter, we check it by always putting it back in. So 10 over 5, excuse me, 10 over 15, does that equal 2 over 3? And you can look at that as your equivalent fractions. 2 times 5 equals 10. 3 times 5 equals 15. So it does check, and our answer is x equals 15. All right, so let's go to the next one. And as I said, equivalent fractions, yeah, it's easy to check and easy to do, but sometimes we can't do that. So that's why it's really important to remember your how to cross multiply. So let's go do that again. And when I do that, I'm going to, it didn't give it to me. Let's try that again. I'm going to write that product on that side and this product on that side. So when I write that, it's going to be 22 times x equals 2 times 60 minus x. So this side has not changed, 22x. This I've got to distribute. So that's going to equal 120 minus 2x. And then I'm going to add 2x to both sides. That will give me 24x equals 120. And then I'm going to divide both sides by 24 and find out that x equals 5. And before I box it, I'm going to come over here and check it. Let's write down, this is my check. 22 over 60 minus x equals, oh, sorry, we're supposed to be plugging in for x. 22 over 60 minus 5, does that equal 2 over 5? Well, 60 minus 5 is 55. 22 over 55 does reduce to 2 over 5. So I know that I do have the right answer, and x equals 5. Okay, And the last two problems we need to talk about are applications of that, which means we get to do word problems. And again, we've talked about this before with our similar triangles. So what I want you to know, when you do these problems, there will always be a statement in there that will give you a ratio. The property tax on a house with an assessed value of $250,000 is $3,500. That right there is a comparison of two numbers. Okay? And that's what we're going to use to solve it. Determine the property tax on a house with an assessed value of $420,000, assuming the same tax rate. So I have a value of my house, and then I have a tax on my house. And the one that they gave me, the value was 250,000 and the tax was 3,500. Okay? Determine the property tax. That means I'm looking for the one on the bottom, and the top, of course, is my 420,000. Anytime you have zeros on top, it's like dividing that number by 10 each time you cross out a zero. So now I'm going to cross multiply, and on the left side I'm going to have 2,500 times x, and on the right side I'm going to have 35 times 420,000, which is 14,700,000. And then I'm going to divide both sides by 2,500 and find out that x equals 5880. Now, it's a word problem, so what's the property tax? Dollars, $5,880. Okay, last problem. Wildlife biologists catch, tag, and then release 120 deer back into a wildlife refuge. 2 weeks later, they observe a sample of 150 deer, 25 of which are tagged. So there is our comparison of two numbers right there. That's going to be our ratio. Assuming the ratio of tagged deer in the sample holds for all deer in the refuge, approximately how many deer are there in the refuge? So my ratio is deer to tagged. Does it matter which one goes on top and which one goes on bottom? Absolutely not. Just got to be consistent. So deer, I have 150 deer, 25 of which were tagged. How many deer are in the refuge? That means I'm looking for this number. And how many were tagged? Well, they tell you back up here at the very beginning that 120 were tagged. Okay, I cannot cross out those zeros. They're not on the same side of the equation, top to bottom. So I'm going to have to multiply. 150 times 120 is 100, actually it's 18,000, equals 25x. Divide both sides by 25. And we're going to find out that 720 is equal to x. So to answer my question, approximately how many deer are in the refuge? We're going to say 720 deer. And that's our modeling with proportions. So come see me if you have any questions. All of your classwork is on the back of your note sheet.